share this lonely view. Don't believe it. Slitting my throat is so
Hello. Hello, everyone. Thank you so much for being here. We're just going to wait 2 more minutes, so just giving 5 minutes. If you want, there's here a QR code for questions. We're going to do here an informal conversation about the future of Android development. And if you want to make a game while you wait, you can look at this picture and try to identify the 10 different desserts that we have on Android. So, good luck.
Hello. Hey.
Som, 2 som.
Ok. Ah. So, hello everyone. Welcome to this fireside chat. The goal here is to have an informal conversation about the future of Android development. We're going to talk about a lot of things, and we invite you, the audience, to join us on Slido and ask us any question. Or if you want, you can just put your hands up, we'll throw you a microphone, and you can just ask us anything. Before we start, let me just say thank you for being here. I know that it's too early. It's the second day of a conference. So let's try to just move us a bit. So I'm going to ask everyone to give the biggest round of applause ever to our amazing speakers. So 1, 2, 3. Energy? Anyone needs coffee? Okay. Okay, so once again, thank you for being here. I'm going to start by introducing myself, and then I'm going to give the microphone to each one of them so you can know them a bit better. My name is Carlos Mota. I'm an Android developer. I've been developing for Android since Cupcake, that you can find somewhere on that picture. And recently, or for the past 5 years, so not so recently, I've been working with Kotlin multi-platform. I'm going to also give a talk next, so if you want to know more about KMP and Compose multi-platform, join me. Shameless advertisement.
Hey everyone, Ahmed Tekiwer. I am a software engineer, currently based in the Netherlands. I used to live in Cape Town in South Africa. I've been a software engineer probably since 2011, but for Android since 2015. I'm also a Google developer expert for Android. Yeah.
Hello everyone. Yeah, my name is Sasha Denisov. I'm based in Berlin. I work as a chief software engineer for EPAM systems, and I'm Flutter developer and used to be Android developer before. So I used to be C++ developer, then .NET developer, then Java backend developer, then Android developer, and finally Flutter. Yes, a long way to go. Yeah, but Android was in this list. Yeah. So I'm a Google developer expert in Flutter, Dart, and Firebase. And yeah, what else? So mostly I'm working on fully cross-platform solutions with many platforms, and mobile, TV, web, everything.
I have already a microphone. My name is Sergio Sastre. I've been doing Android development for over 10 years. I'm based in Munich, working for Deutsche Bahn as a consultant, so I'm not intern there. And I'm also an Android GDE.
Hi folks, my name is John O'Reilly. I live in Galway in the west of Ireland. Work remotely for Crack Technology based in London. I've been doing Android development since about 2010. Working on both Android and iOS, I guess, over the last 15 years. Nowadays, doing mostly mobile KMP-based development, and also a GDE for Kotlin.
Hi, I'm Marcelo. I work in the Android X architecture components team at Google. I'm based in London. Yeah.
I'm Kinara. I'm based in Berlin, but I work in a company called IoKey in Frankfurt. It's a mobility company, part of Droidcon. I've been working in Android for about 7 years now, and yeah, I really enjoy doing Android with compose and animations for the most part. Also a lot of modularization. I think that's what I'm really interested in.
Morning, everyone. My name is Julien Salvi, based in Paris. I'm a lead Android engineer for a company called Aircall. GDE for 3 years now, and that's basically it.
Now we're going to go to each one of you in the audience so we can know you better. Joking. So I've got here a cool tablet just so I can look a bit professional, and I'm going to start with a couple of questions so we can start our fireside chat. As I mentioned previously, you can have this QR code or access directly to Slido. I'm monitoring the questions, so feel free to ask us anything. So my first question, and here to introduce the topic, we're talking about the future of mobile development or the future of Android development, and I think it's important to also revisit the past. So we're Android developers for several years now, and I think it's important, and I'm going to Okay. This usually happens at the end for me to shut up. So I'm going to start, I think with Julian had an amazing talk, I think it was last year, about 10 years of Android development. And let's revisit a bit the past and let's talk a bit about what each one of you prefer on Android development. What was the turning point for you where you felt, okay, Android is really for me, I love this technology and the future's changed. I can start a bit with this. For me, the turning point on Android first was when I realized that I wasn't the only one using the apps that I've developed, and it was a really cool feeling to see that I could just look to the other side of a place and see someone using my apps. But when my developer experience improved was when we switched from Eclipse to Android Studio, and I stopped renting towards my computer, and the development started to be easier. That was the turning point for me. Julian, what you felt that it was like the best feature that was out there that improved our lives as developers?
Well, that's a difficult question.
I like to start
I've been around, started Android development in 2011. It was definitely not mature at that time with Eclipse, all the things but starting the Android development was quite straightforward. I had an Android phone and with small knowledge of Java, you can just build quite amazing things. But what changed really for me, I think the Kotlin, when it was officially in the system, definitely improved and like was the starting point of like so many good things. And also when Google like released lots of like compat libraries, it make our job much more easier than like pulling like a shady third-party libraries to do lots of things.
I don't know if I'm going to ask Sasha, do you want to say what was the best for Android development for you? This is a tricky question for him.
What's the best for Android? What?
The best feature that Google released for Android?
I was playing with AI on device, and probably one of the nice features that Google added to new Android is Gemini Nano that integrated to device already, and you don't need to upload your AI model yourself. So because, in my opinion, so now like everything in mobile is moving to new type of interaction. So now is everything mostly based on UI interaction, like kind of pull model when the user install application, pull it, and everything. But I suppose future of applications is mostly AI thing when AI will push user to do something. So from pull model to push model. Yeah, developing of AI on device is, I think, most important part now. But it's only Android thing. I suppose Apple also should do something, but we are at Android conference, yeah? We discuss Android only.
Okay, so we took 10 minutes to say the first time AI, okay? I was hoping that you were going to say Flutter. Okay, so Flutter wasn't the best thing.
No, Flutter is not related to Android, so that's why. Flutter is just UI toolkit on top of, so you asked what Google released for Android. So if Google released at all, in this case, yeah. But Flutter just still develop it. So the last year it was interesting announce that brought a lot of conversations because Google announced that Kotlin multi-platform now is officially cross-platform solution. And I've got a lot of questions. What will happen with Flutter now if Kotlin multi-platform is officially supported? But Flutter also officially supported cross-platform solution. So they are not competitors, yeah, because they have different purposes. It's also official answer by Google. But yeah, it's a really nice move for cross-platform development, the stable support of Kotlin multi-platform, because maybe when in future JetBrains will release Compose for iOS, in this case, maybe it will be a really nice competitor for platform for Flutter in UI part too. So we'll see. Kotlin multi-platform, yeah, it's really great.
That's a great point. That was the next topic that I wanted to discuss a bit, which is one of the biggest, I'm going to say for me, announcements of Google I/O was the release or the public release saying that Google supported Kotlin multi-platform, and we see new libraries now being giving that support. And before we started this conversation, I was just saying that I was really happy because yesterday or 2 days ago there was a release of the adaptive window that we can. The adaptive window where we have support for multi-platform, and we can basically compile our apps and run them. We can basically compile our apps and run them on Android and iOS, and Okay. I'm holding it wrong. Hello? Mas continuo? Okay. Where was I? So yeah, it was introduced, it was announced the support for Kotlin multi-platform, which is great. And Sasha mentioned a really cool topic, or a really cool thing, which is sometimes we often say that one technology is better than the other, and this is never the case for us as developers. So technology depends on the product that you're going to do. It depends on your team, your background, and there's no biggest advantage here across Flutter, React Native, and so on. It depends on the team, and perhaps I'm going to start now with John. Do you have, okay. John is known for being, before we start, I have a question for you, John, which is, how are you able to, to tweet what's going to happen on Kotlin multi-platform before JetBrains?
Yeah, I think some of the JetBrains guys have given me a hard time about that over the years. Yeah, I think the answer is I clearly spend too much time on Twitter, too much time online. So, yeah.
And now the real question, John has a lot of libraries, a lot of samples out there built with Kotlin multi-platform, with Compose multi-platform. He's been doing this for 5 years.
Yeah, about end of 2018, I guess I started looking into it. Yeah.
Yeah, and he's keeping this project updated. So it's really cool to see. If you look at the brand, at the history of the repositories, you can see how he evolved the libraries that he was using, how he evolved the logic. It's like a piece of history that should go to the National Museum one day. But my question here for you is, what made you choose Kotlin multi-platform? And after 5 years that you started doing that as a side project, you're still working on it, and now you're moving to work them even more.
Yeah, absolutely. So, I mean, I've been working as a software developer for, I think it's 34 years now. And over that period of time, and particularly on mobile over the last 15 years, I've sort of encountered or been sort of forced to, I guess, partake, if that's the right way of putting it, into various code sharing approaches. On mobile, sort of 10 years ago, I guess we would have done a lot of sort of C++ based code sharing. And I think from that perspective, when I came across KMP, as I said, in late 2018, it just sort of immediately appealed as this is the sort of first sane approach, both sane and pragmatic approach to code sharing on mobile in particular. Following on from obviously the development or the availability of Kotlin in general, I think everyone loves using Kotlin, and then when the approach to code sharing based on Kotlin came out, it was definitely something that was very attractive. And it was rough in those early days. As I sort of touched on my talk, I mean, I think there's over 1,000 libraries available now in KMP, at least I think. Back then there was maybe a handful. They were very rough and ready. The concurrency approach was very sort of hard to use, very limiting. So it's been very satisfying. It's been a steady increase in maturity over those 5 years. A lot more libraries. The developer ecosystem has improved. JetBrains have put a lot more resources into it. There's very few things you can't do now with Kotlin multi-platform. And in general, of course, the approach of Kotlin multi-platform is that you can dip into the platform whenever you need to anyway. And then I guess over the last year or so, the development of Compose multi-platform has been amazing. This is sort of my day job these days, is developing a purely Compose multi-platform based application. So the lines are getting blurred. When we talk about KMP or CMP, it's very hard nowadays to sort of say, well, which is which? Is CMP kind of part of KMP? But yeah, it's as I said, it's sort of 5 years on. So I think we've got to a very mature stage in the ecosystem. It's not the kind of questions, the articles you see these days are not necessarily anymore about whether you should use it, but how you should use it, and various scenarios that it gets used in.
I don't know if anyone wants to jump in more on multi-platform. Okay.
I just wanted to mention the case about using Flutter or Kotlin multi-platform. We even did an experiment using both of them in one application. UI in Flutter, business logic on Kotlin multi-platform. It works. So the main question, why you should, but it works really. So native is just a layer between. But yeah, if you have already implemented logic with Kotlin, so probably it can be a case. Yeah. When you want to move your application to cross-platform, you can move business logic to Kotlin multi-platform and implement UI with Flutter. Why not?
Yeah, a really cool thing, on my opinion, of course, also in KMP, is that, yeah, it's for developing the business logic. It doesn't have the goal of sharing everything. You decide what you want to share, and you can use it with native, with Kotlin, or with Swift, or you can use it with Flutter. It's up to the development team or to the managers to decide what makes sense for them. I also wanted to talk a bit to Kinera. I think you've worked with React Native, right? Since we're talking about here about cross-platform solutions, can you give us a bit your input on React Native? Perhaps I should have started with asking, so here, who's working with Kotlin multi-platform? Can you just put your hands up? Okay. Who wants to start working with Kotlin multi-platform? Okay, nice. Who's working with Flutter? And who wants to start working with Flutter? I wasn't expecting that, but cool. Out of curiosity, who's working with React Native? Okay. I'm not working, I just want to see your hands.
I wouldn't be a lobbyist for React Native, to be honest. I worked on it for about 2 years, and it wasn't the best experience, but I think it works best when we're doing it with native and not entirely independently. If you have a part of your app that is really the same between, for example, Android and iOS, and the company that I was working for before had all of the checkout and the orders, all of that part that was really common between the two of them in React Native. But the rest of the app that is more user-intuitive, like home, and all of the buying part of it was in native, and that's what gives the user that intuitive experience on a native device. Right? But then when it comes to things like, you're checking your orders, you don't really look for a experience, you're looking for the information. So it really depends upon what you're looking for in that particular feature, and in that case, you look at what you can do with it. I think it's not a one-for-all solution, especially with React Native. The performance does lag a little bit, so you really have to think about that balance between native and React Native. But just jumping in on the KMP discussion also in my current company, we're currently extracting some of the modules out to KMP. Like we have our domain API layer that is out in a separate module, and we're using it between iOS and Android for now. That seemed like a good first step. So it looks like something you can do step by step. It doesn't have to be all at once the same way that we do with Compose, right? So we can do step by step. There is a wide area of space that you have, a lot of lateral sort of movement that you can do in this space. So there are no rules, which gives you that thing where you can go half-seas on everything and then have a big mess of your app. But you can it helps you figure out what goes best, and it works. So that's the best part of it, I think.
Yeah, you touched a point that I wanted exactly to ask, and perhaps, I don't know if I'm asking too much, but so Marcel, Google now is pushing a couple of libraries to multi-platform, which is great, and I have a question. I've been having this question since I saw the first release, which is how, and I don't know how much you can say about this, but for instance, you're giving support to new technology, you're giving support to more platforms. How's the process of giving this support? So for instance, the view model or the window size that was released, how do you add these multiple targets? How you select this library, and how is the process of giving support for iOS, for desktop, for WebAssembly? Can you talk a bit about this process? So for instance, more people that have their libraries built for Android that can also give support for iOS, for instance.
Yeah, so basically there are two types of KMP support. That is the KMP compatibility and KMP support. Compatibility is basically we convert the library to make it run on common source sets on KMP projects. You can basically, Lifecycle is an example of KMP compatibility. You can put it there, and you still need to integrate that by yourself, or you need to use a library such as Navigation Compose from JetBrains, the multi-platform variant, to get this integration. And there is the KMP support, which is out of the box, such as Room. You can just add it to the project and it works. And actually, we don't know exactly which libraries will reach each type of support, because we're still learning like what does make sense. There are conversations about should we actually provide integration with Swift UI directly from view model or not? How much support should we provide and all of that? That is happening, like how much commitment should happen this sense? Or we should just provide the APIs in multi-platform and let people integrate by themselves. From a tooling point of view, we do build our own artifacts for iOS and all other platforms, except I think Wasm and JavaScript. That is still built by JetBrains on their fork. For the Android X libraries, not Compose. Compose, I think, is mostly built by JetBrains. And we do run like all the tests, everything internally by ourselves, and we test again all of these platforms ourselves as well. Does that answer the question?
Yeah, thank you. I don't know if it's possible to also answer this, but so did you find the process of giving that support straightforward, or it involved more breaking something until you're able to give that support? Did you find it easy to give this support, or you spent through a lot of pain to give support to multiple platforms?
Yeah, for the libraries that I did convert to KMP, they were not straightforward because they were built for Java like 9, 10 years ago. So you do have all of these APIs designed from a completely different world and different APIs and all of that, like for XML view to UI to Kit or Java first. So it's more like a trial kind of thing. We just try to check the public API, try to figure out the things that we can convert easy, the things that we cannot, and we try to map them. We also like in the navigation, in the lifecycle libraries that we converted, the goal was actually to get navigation converted. So like what we normally do is we try to figure out what makes sense to go to multi-platform. We try to figure out what are the dependencies of this thing that we want to convert. For navigation was the lifecycle. And then we start to convert from the leaf, all the modules up to the main one. Mm-hmm. And we mostly go learning on the way, because like we try to plan ahead, like what is going to be the need for that library, but most of the time things will just break on the way. Like the Kotlin compiler we generate a bytecode is slightly different, and now we need to figure out why they generate slightly different, and then we need to talk with JetBrains, open issues with them. Sometimes we need to fix that by ourselves. So it's more going, trying to figure out like how to approach that. And for Android X itself, we have this core principle of backward compatibility. Mm-hmm. So that is something that we need to keep in mind. It is not as easy as just dropping the old API and introduce a new Kotlin one. We need to always, maintain binary compatibility. We have a lot of tooling to check binary compatibility, and that's something that we don't bypass at all, like ever.
Okay, nice. Yeah, and you mentioned something that I think it's well worth mentioning here, and I don't know if you all agree with me, but for instance, since I've jumped in Kotlin multi-platform, JetBrains on the Kotlin Lang Slack has been amazing. They put a question, sometimes might not be even a smart question, and they answer it, and they're really trying to push things forward. And usually, if you open an issue, a ticket, they will reply to it and try to help you find a solution. That's pretty cool for someone that's trying a new technology to have that support. I was opening here Slido. Thank you. I'm going to start with the question with more votes. So, why is there no milk for the coffee? Okay. I don't know. We're going to try to see why. So the second one, will the future be Kotlin multi-platform, Flutter, or React Native? I think we've answered this a bit by saying that we don't have a magic ball. I don't know if anyone wants to say something. You want? Will the future be Kotlin multi-platform, Flutter, or React Native? If there is one of these technologies that will stand out, not the others. Do you want to? Okay.
In my opinion, so all of this technology will be in future. So because often business is make a decision which technologies will be used, not developers. And from business perspective, these different technologies are more suitable for different purposes. For example, if you have a project like that, support as many platforms as possible, so one technology is better than if a project need like more something native feeling and so on. Maybe it's better native implementation. So, but the thing is that decision of what technology will be used is not only technology based. It's a business reason based sometimes. Which team do you have? How many people do you hire? What situation on the market and so on. And all of this technology is moving in a little bit different direction for different purposes and with different capabilities from business perspective. So I suppose all of them will be developed in the future and will be used anyway.
Okay, following our questions, there is one here that I really liked, which is, what kind of books are you reading? I think it's what kind of books are you reading? I think it's a valid question. I don't know if it's technical or romance or thrillers or whatever, but I don't know. There is any technical book that any of you are reading or read that it's worth sharing with the audience?
I guess from my side, I'm always just trying to improve myself. So I always just pick up whatever books. So some people would recommend, like, there's a book called Clean Code. I think that teaches you how to write code with the mindset that when you write it now, this type of code, it needs to last a very long time. So you need to basically build future-proof type code, and the way that you approach certain decisions, the way you write your variables, the way you create your functions, all that stuff. So that's actually important, because that'll actually reduce code smell and help you have a code base that you can actually pass on to other people, and other people can understand the way you've written your code. Yeah, and then I guess just soft skills books as well. That's normally what I do as well. So the idea is to not just focus on tech, but also on your abilities as well. So if you want to branch out, maybe change your role to something else, from a tech lead to maybe you want to be a software engineer, those type of things. Yeah.
I think for me, I'm not much of a nonfiction reader, but I read Functional Kotlin last year, and I think that's really interesting. It might not be what you would use in everyday code, but I think just the understanding of how the same code that you write can be written in a different way, I think it's really interesting. That was definitely one book that I would recommend reading.
So I can recommend one book. It's not a technical one. Yeah, it's not a technical one. But what I would like to say, nowadays teams that develop products really often completely international, with people from different countries, different cultural background. So, and I read one nice book with name Cultural Map that and give you more understanding of people with different cultural background to work together better. So it's really insightful for me. It was,
yeah, for me it's exactly what Ahmed said. Like clean code for me was very, very important. I mean, it made me click in my head yeah, how to write software. I think we should focus on books that talk about fundamentals, not about a specific technology, because that changes over time. Now it's Compose, maybe, I really love Compose, but maybe later it will be Compose 2, yeah, who knows. And really understanding the fundamentals, how to write good code that can be maintained, I think is for me the key.
Yeah, not really too much. I guess I've sort of moved over the time away from books a little bit to more articles. I guess that's the way we consume a lot of information these days. But I suppose one specific book, and it is technical, I guess, is very good, that I definitely recommend is Kotlin in Action. A number of the JetBrains folks joined together to write it. So definitely, if you're not reading that already, I'd definitely recommend it.
Yeah, I would recommend the Philosophy of Software Design. Yeah, it's just a really quick book and easy to read, and it's very valuable. Like, it's about designing APIs and make it easier and better.
So perhaps going to the next question. We got a couple of questions about AI.
Dancing on the hood in the middle of the woods, I'm alone. My
Quick book and easy to read, and
Most of them seem to be a bit worrying about the future of Android development, the future of programmers. So my question, the question here is, how can we leverage the power of AI in our role as Android developers? How can we improve, how you can be more productive with AI? And are we worried about our jobs? I don't know if...
I have the microphone, so I will continue. Yeah, for me, I think AI is a tool that is actually helping a lot, but depending on how you use it. Yeah, whenever I ask AI, let's say ChatGPT or BART or whatever, I don't get the answers that I want, and I continue asking and asking, this prompt engineering, how they call it, till I get something that still does not work. So for that use case, I think there's still a long way to go. But what really helps me, for example, when I'm doing development, is when I get stuck. I try doing things and I like, okay, I'm out of ideas. Yeah, how can I continue with this? So then I start asking ChatGPT, BART, whatever, and then I start getting this kind of enlightenment. Yeah, okay, I could also try this, and then sometimes it actually works. But yeah, just using code that is given to me, at least for Android, I don't know for other technologies, still there is some way to go. My personal opinion, of course. I don't know if somebody wants to say something else. Yeah.
We've been trying out testing Copilot for our team. And I think it's interesting because more contextually, like very small context in a file or so, it can help a little bit because it's just looking at that particular piece of code. But in Android, we're always cross-referencing and going back and forth from a lot of different things, which, like you said, is really hard for AI to, at least at this point in time, to be able to take over our jobs. But I think it's still helpful in terms of boilerplate. If you're setting up your files or if you're writing tests that are pretty repetitive, I think in those cases, it does cut down on a lot of developer workload. And in that case, you can focus more on the things that really need your attention. So in that sense, in terms of sort of narrowing down what you can work on, it helps. But I think that's my opinion for now.
What I want to add, like first, come to see my talk after lunch. It's all about like how you can leverage your skill and your app about AI. But yeah, I think there are two separate things, like bringing AI as an assistant, like in your daily task, like it can help you a lot. At our company, we are using Copilot in Android Studio, and like even for writing tests, we gain a lot of time, especially to automate this kind of not easy, but like a long task sometimes. We gain much more velocity, and we can like find a lot of good use case about AI. Sometimes you need like to deport it on the server side, but with lots of tools like MLKit, MediaPipe, and or TensorFlow, you can do some really good thing on device. At our company, we take good advantage of MLKit, like to scan documents and send it as a MMS, for example. And a lot of also good like use cases on the server side, like to translate, transcript audio and stuff like that. So capture your need and then use the right tool to do it.
Thank you. We have here a question directly for you, Marcel. Can you tell us which tools do you use for binary compatibility tests? Or I don't know if it's something.
Yeah, so on Android X repo, if you clone it, we do have MetaLava integrated to that. So if you do a /gradle with a W wrapper, check API, you're going to run against the MetaLava binary compatibility checks. And if there is any difference, you're going to get the output of what has changed in the API. If I remember correct, we do run that but against the JVM and the binary, the native ABI API. So basically, we check the API for both native and JVM. Yeah, and we use MetaLava. So I think MetaLava is an open source project, if I remember correct. So you can actually check online.
Thank you. There is a question here that as an Android developer, I really find it really interesting in the sense that I've went through this more times than I want to admit, which is, so Google is launching a lot of libraries nowadays. Once I counted that every 15 days, Google launched 77 updates on their libraries. So please start to sleep more and give us time to keep up with it. But the question here is, so since a lot changed, we went to architecture components, we went to Kotlin, to Compose. Now, the question, okay. So these sometimes mean that we're going to do big refactors over an app. So nowadays, Android was released in 2008, so we've got apps that exist for the past 10 years. So how can developers and companies keep fighting technical debts and keep refactoring an app, knowing that they need to implement features? Do you have to all of you, do you have any recommendation how you deal with it, with your technical debt, with these new libraries that keep launching and sometimes you need to update our code to it?
Well, I can reply, basically on how to deal with technical debt, not about new APIs and all that stuff. Okay, so I've been doing consulting for quite a long time, so I've worked in several projects, different companies, and all of them have technical debt, but there are some projects in which there was much less technical debt as in others. And I think there were like mainly 2 points that distinguish these companies from those that have more technical debt. One of them is continuous refactoring, and the other one is not to use Scrum. Let me talk a little bit more about this. So without going into much detail, like continuous refactoring, okay? So when people hear about refactoring, they think about a big thing. Yeah, like you accumulate technical debt, and after a while, it grew up so much that you cannot make changes easily, so you have to do a refactoring. With continuous refactoring, it's different. Every time that you are implementing a feature, you are doing a small refactoring, like splitting one class into 2 classes, whatever single responsibility, moving methods around, and so on. And for that, you need a good testing strategy. Yeah, but the problem is that in most of the companies, testing is not good, because you make some changes and then the tests break without reason because you are just refactoring. You are not changing behavior. Yeah, but I don't want to go deep into this. But basically, continuous refactoring is one of the solutions. The second one is not to use Scrum, because I've been using Scrum in most of the projects, and I still have to see one project in which it works. In one of the projects with minimal technical debt, we were using extreme programming. Was awesome project, by the way. But the problem with the Scrum that I see is that, okay, you plan things for maybe, let's say, 2 weeks, and maybe the day before the sprint finishes, you are not done with that one ticket, but not too much left. Yeah, let's say that maybe in 1 more day you could finish it. Then comes the PO and starts putting pressure like, why don't you finish? Maybe we can remove the test, or maybe we can, instead of implementing the full feature, just split it and we do this in the next sprint. And of course, you as a developer feel the pressure and you say, okay, let's do it. In the end, you will never do it, or you will do it in 2 weeks. or in 3 weeks. And personally, I have much better experience with Kanban or with XP. And I think we should really talk to management if we can influence the way we work and we use these frameworks. Maybe I talk too much.
Yes, so to agree with Sergio as well, so there are kind of two approaches that we tend to take. The first one is to try and ensure that when you are then working on a feature and you do see, so we always tend to put a to-do, and a to-do always has to have a ticket or a task assigned to it. And whenever you're touching a piece of code and you come across this to-do to try and address that, that way it's not going to linger for a long time. Then also, we as a team tend to set aside days. We call them chapter days because every competency is kind of like a chapter. So we then tend to set aside a complete day where we're working on features within the app. That way we're always continuously working on the project itself. We're not letting things just linger because the more that you do it, then yes, it's actually going to start piling up. So the idea, like Sergio as well, to just continually try to improve your code as much as you can. Whenever you are actually adding a new feature, try and work on whatever it is, this technical debt that you might have had that you still need to address. Yeah, we've seen that it actually does help. It might increase your time. So yes, when you're working in Scrum, you might then, your task, which is a 2, might end up being a 5 because you're now having to work on the test and so forth. But in the long run, you're actually going to have a healthy code base instead of one that's going to have issues that are just piling up over time.
Thank you. We received more questions that I wasn't expecting, so thank you for everyone. Unfortunately, we have a limit on our time slot. Thank you everyone for being here. Thank you for all your questions. Talk with us after this talk during the breaks. We didn't answer to all the questions. Sorry about that, but we're going to still be here, so feel free to approach us. And thank you so much for being here and to attending this fireside chat. And thank you to everyone here that accepted the invitation to be here. Thank you. Hello? Hello? Ah, okay. Hello, everyone. It's me again. Thank you. Are you still all awake? So let's repeat the thing and let's give a big round of applause to all of you that are still here. Thank you. Louder, come on. Hello. So welcome to this Brave New World talk. I've got here a QR code because I love QR codes. This is just to understand what you're looking for on a cross-platform solution. So feel free to scan this and just say what you're looking for. Once again, this is public, so I am not responsible for the words that you're going to see there. Hola. It's always a pleasure to be speaking here in Lisbon. I'm Portuguese, so I've got that. You can find me on Twitter or on @X at CFOSMOT. I'm an Android GDE. I'm an Android and KMP craftsman and advocate for Kotlin multi-platform. I'm a writer at Codev. I love to travel. I love photography and running. Lately, only the first two. And I'm really happy to be here at Droidcon. I've got a couple of samples, a couple of articles, a couple of source codes, and instead of having links throughout the slides, I decided, once again, a QR code. And you can find everything on my link tree. So you can just scan this, and there's the presentation, the source code that I've created for this presentation. You've got all the links from Google, from Android, from JetBrains, everything in a single place. I'm also going to tweet afterwards all of this. So, meet mobile development. So the first question that we have, and doing a bit of following to what we did on the fireside chat, is how to develop an app. So there are a lot of ways that are going to make you to develop an app. You might have an idea of something that you want to build. You might be paid to develop something, or you just want to test a library or a framework or something. And the first thing that it's important, and why I'm mentioning this, is the tool that you're going to select depends a lot on your type of project. If it's a proof of concept, if it's a project that you're going to develop for the next 10 years, 5 years, or so on. Next, it's going to depend also in the team that you have. If you've got just a single developer, you might need to use a cross-platform tool. Or if you have multiple people that you can allocate, perhaps you can have people per platform. Also, the team background is really important. For instance, imagine that if your team has web background, perhaps you're going to use React Native, and you're not going to use a native solution. Next, it's important to understand how much time do you have to start doing your project and to ship the first version. So here goes the timeline. So are you already behind schedule? Are you on schedule? Can you allocate or hire more people to help you doing your project? Can't you? And finally, it's important to understand if you want to target a single platform or if you want to target everything. In this case, Android, iOS, desktop, web, and so on. So when you reach this point, we can select a lot of tools. And one of these tools is not like the others because it's no longer here with us. It's called Xamarin, but the rest of these solutions still exist nowadays and are used by a lot of projects nowadays. So this here to say that although we do native development, there are also tools that you can use to make your life easier. Once again, I'm going to advocate Kotlin multi-platform here, but it's up to you to select any of these tools. I want just to show you something about these tools, and now I'm going to be the dev's advocate, which is, I'm going to show you this. I was on Facebook I was in Instagram trying to post something on Facebook. And I'm just going to reply this again. And look to the spinner, okay? And again. So Meta is a company with hundreds of developers, and sharing something from Instagram to Facebook still shows a spinner that existed 10 years ago when I was starting Android development. So that spinner is like 1.5 or Android 2.0 or something like that. And this is important because for me this is the worst thing about multi-platform cross-platform development, which is sometimes the UI is not updated. Someone didn't build that part of their app, and you're still seeing old things. And we're talking about a company with hundreds of developers. Next, we always have this question. This is a Flutter application that was published by this user, and anyone can spot an error here? I'm going to say that this is an iPhone. And the reason why I'm saying this is because iPhones doesn't have this type of dialogues. And this ruins the experience of an, this is an iPhone, and iPhone doesn't have this type of dialogues, and this ruins the experience of an iPhone user. And remember that when you're building an app, nowadays there are hundreds or dozens of similar apps, and you want to give the best experience to your users. And from something that I've really understood from usability tests that I was doing, is that iOS users, iPhone users, are really picky to their UI. And if it's a bit strange, a bit different from what they're used to, they don't usually like those apps. So, a bit of summing up everything. Be careful with the demo effect, and this is also valid for today's talk. So I'm going to show you that Kotlin multi-platform is amazing and Compose multi-platform is amazing, but remember that this is a talk. I've created a sample project to show you, and this might not be the case for when you're going to test it on your requirements, on your use cases. Remember that cross-platform solutions like these ones are framework dependent. Sometimes there are features that are missing, especially if only exists on Android or only exists on iOS. This is an arguable question, but it's a slower performance. If you want to have the same performance, sometimes you need to do a lot of optimizations, but you're going to use time to allocate time to make those optimizations. And you're committing all your code to a single framework, and do we know if from 5 years from now, are you still going to have that framework available, or are you going to redesign your entire project and start using another one? So this is why I'm going to show you the power of Kotlin multi-platform. So the first thing that is important to mention is that Kotlin multi-platform, it's an SDK, okay? This is the greatest thing about Kotlin multi-platform, is that it's an SDK that you can use, and you can give this support for your apps. Also, it's developed in a language that we all love, okay, Kotlin, okay? Show me the love. I was expecting a bit more. Show me the love. And the goal here is not to share everything, okay? Like all of those other tools, they want to have a single code base that you can share across all platforms. Here, the goal is to share the business logic. In other words, what makes sense for your app. So instead of building your network requests in Retrofit on Android or Alamofire in iOS, you're going to use Ktor and develop that once. You decide what you want to share. So I mentioned network requests, but you can share just your DTOs, your objects that can be shared across server, across the mobile apps, across the desktop. You decide what makes sense to share for you. And finally, you can have your UI developed natively, or you can also use a tool like framework like Flutter, or now you can use Compose multi-platform, and you can also leverage the power of Compose and share your UI. It's up to you, it's up to your projects, you decide. So Kotlin multi-platform exists for a lot of platforms. You've got for WebAssembly, GS, JVM, native, where you include the desktop, and of course iOS, tvOS, watchOS, and so on, and Android, and once again everywhere. TV, Wear, Auto, Automotive, fridges, if they start shipping for fridges. Supports Android, it supports Kotlin multi-platform. The question that always asks us, apps in production with Kotlin multi-platform, there are hundreds of applications nowadays on the store. And once again, the question, what to share? And I want to give emphasis to this point because when we learn some new technology, we always want to make big refactors. We want to use that. I was talking here before, and there was a good expression that was hype-driven development. And okay, there's Kotlin multi-platform, I want to share everything. There's no need to share everything. My advice is not share everything at first. Okay, you're going to learn a new technology, your team needs to be comfortable with this new technology, iOS developers need to be comfortable with this new technology, so start by sharing small things. Start by sharing the objects, as I mentioned, or start by sharing the network requests. Start sharing small, and if you feel confident, keep adding new features to it. one of the things that we also use for convincing iOS developer is share your databases. You can use SQLite for this, or you can now use Room for this, as we keep having more support from Google to Kotlin multi-platform. So in the common goal, different apps share different features. How to share? I'm going just to give you a simple example. When you look at Kotlin multi-platform, you already have a specific set of libraries. And if you look at the last service that JetBrains did, the libraries increased a lot. So we've got an exponential curve with the libraries being launched. Just a small examples, we've got a couple of libraries that are created by JetBrains. So we've got the coroutines, Ktor, serialization, datetime, and the libraries that nowadays we keep seeing from the community almost gives you everything. Okay, you've got the multi-platform Swift package, you've got Coil, you've got Reactive, you've got WebRTC KMP, the Material Tree, Clock, OKIO. You've got a lot of people, a lot of companies creating these libraries that start to have a lot of traction. And when you're going to start developing for Kotlin multi-platform, nowadays, I would say that 90% of the times there is already a library that have support for Android and iOS, and of course desktop. How to share? Add support for platform-specific features. When you talk about Kotlin multi-platform, there is always a joke that you need to use expect and actual. So how does this work? Imagine a simple example here. I'm running my app on an Android and I want to see Android written. If I'm running my app on iOS, I want to see iOS written there, on desktop, and so on. So the way that we have to do this is we're going to use the keyword here, expect, and we're going to define this on a folder called common main. Common main, there on top, it's where your source code exists, okay? All your code now is inside the folder common main. Next, since we're targeting Android, iOS, and desktop, we're going to say that what we expect someone to define, so we expect someone that's going to define name, and actually, and now if you see there, we move to Android main, we're going to say that name on Android means Android, and for the rest of the platforms means the platform name. As you can see, I'm moving from folder to folder, so I was on common main, where I've got my expect declarations, and then I'm going to be on Android main, desktop main, and iOS main, where I'm going to have my actual declarations. Now, if I'm going to run my app, it's going to look like this. So how to start? We're going to have a great workshop today about Kotlin multi-platform. I'm just going to give you some simple solutions to start. So there's the Kotlin multi-platform plugin. If you start Android Studio, now you have got templates for Kotlin multi-platform and Compose multi-platform. You can also use Fleet by JetBrains. It's the IDE that has support also for built-in iOS development. You can also use the Kotlin multi-platform wizard. So imagine that you want to target Android and web, for instance. You can just click on those checkboxes and hit download, and it will generate the project. You can select the targets that you want directly from this wizard. And of course, there is a really cool project created by TouchLab called CampKit that already has support and already has libraries declared. You've got Ktor already declared there. So it's basically a skeleton of an app, and you just need to develop your features. So challenges that you're going to have, because not everything, of course, it's a breeze. So Android, everything is a breeze. For native, these for me are my main pain points. So first, you need to teach iOS developers, if they're going to build for Kotlin multi-platform, the environment setup. They need to get used to Android Studio. And I don't know your experience with your friends, but typically iOS developers really love Xcode. I'm still to understand why. But they need to learn how to use a different IDE that sometimes they don't understand that easily. Also, you've got higher compilation times. If you're going to compile your frameworks for our iOS, this is going to take you more time than it usually takes if you're going to do things for iOS natively. There's no direct interoperability with Swift, and if you want to have multiple frameworks that are going to talk with each other, you need to have an umbrella framework, meaning that all your frameworks need to be inside one framework. So desktop is quite simple and quick to support. It's quite similar to Android, and you don't need to care about anything. What can help you with these pain points? Basically, there's a really cool tool that I like, which is the Key Doctor. That's going to check if you've got your environment set up, if you're ready to develop for Kotlin multi-platform. It's on Kotlin GitHub. You just need to download it, run it, and that's it. Higher compilation times, my first suggestion is only compile the frameworks that you need. So by default, it's going to compile, debug, and release frameworks. You don't need to compile both if you're just going to compile it to your device. If you're compiling to your device, you don't need to compile for the simulator, so you can select just the target that you want to compile. And with this, you're going to reduce a 20-minute time to a 5-minute time. Also, enable the Key2 compiler, which has a lot of improvements, and you can try to use Kotlin 2.0.10. If I'm not mistaken, it's the latest version, and it has a really good optimizations here. Also, for interoperability with Swift, Ski by TouchLab, they launched a library that's really good and gives you support to create a better experience for iOS developers. This is not required by default, but if you're using enums, if you want to use flows, and if you want iOS developers to have the same experience that they usually have with other frameworks, my advice is to use Ski. So let's talk a bit about Compose. Compose, once again, it's Kotlin. So it's a language that you'll all love. Once again, it's one of the things that I love with these two options is that you've got low risk. You don't need to decide to refactor your entire project to Compose. You can still use XML and Compose at the same time. There's no problem with it. Once again, start small. Start with what makes sense for your app and keep adding new features in the future. Compose makes you develop your apps faster. It allows you to reuse a lot more code, which is great. And in the end, it also improves your developer experience. You don't have the pains of development with XML. Just out of curiosity, who's using Compose here? Just who wants to use Compose? Okay. Good luck. So there are a lot of applications already using Compose on the stores. You know most of these names. This is just to show you that although Compose is recent, if you compare it, of course, with XML, it has 3 years' time, 2 years' time. We already see big names here moving towards Compose. I'm just going to make a small break here with some Kotlin trivia to guarantee that everyone is awake. So I really like this trivia. So the programming language Kotlin got its name after? That was too easy. That's correct. Next question. Before being called Kotlin, what was the first proposed name for the language? Guesses? Before it was named Kotlin, it had a specific code name inside JetBrains. Yeah. Easy. That's correct. And now my favorite one. How many different names do we have for Kotlin multi-platform? Okay, so we have MPP, then we have KMP, then we have KMM, and once again we have KMP. Yeah. So the right answer is 3 as the declaration names that it was announced. Now let's go to the greatest part here, which is Compose multi-platform and taking leverage of everything. This is just a simple example of all the main Compose libraries. Okay, basically we've got the Compose compiler, we've got the Compose runtime, and then I just stacked the UI foundation, material tree, material animation into a group that I call the Compose UI toolkit, just to show you that with Compose multi-platform, basically what happens is we're going to change this Compose UI toolkit from Android to be a version for the desktop, for iOS, and so on. So you still have the compile and runtime, and what changes is this stack. So there's already, of course, applications in production with Compose multi-platform. These are the ones that were announced during Kotlin Conf and Talking with Kotlin. Once again, this doesn't mean that the entire application is built with Compose multi-platform. It means that they have code with Compose on an iOS app. Out of curiosity, the first time that I had Compose code on my iOS app, it was when my can you just cut this video part? I'm joking. One of my iOS developers were on vacation. I wanted to try Compose multi-platform, so I've migrated the settings screen to Compose multi-platform, and I slowly put it inside of an iOS application, and it took them 2 months to realize that the settings weren't made with Swift UI. It was one of my proudest moments. So there's an example that I really like. It's from Chris Bain, the TV application. Basically, as I mentioned with John, this is also a great example of someone that, Chris Baines, that started developing an application 5-10 years ago, and you keep seeing the evolution of the app, going to architecture components, going to Compose, and now going to Compose multi-platform. So what can be shared? Once again, the same question. I'm going to say everything, well, almost everything. And we're going to see how we can share all of these things. So first, we've got an application, and if we're going to use Kotlin multi-platform and Compose multi-platform, we're going to have our business logic in Kotlin multi-platform and our presentation in Compose multi-platform. It's a lot of times the word multi-platform. So typically, we're going to have our databases using SQLite or now with Room. We've got our network using Ktor. This is a library from JetBrains. We're going to use Kotlin X serialization for serializing our data, and we're going to have Kotlin tests for tests. You can also share the tests, which is great because you can only develop them once. Now comes the difficult part, which is the presentation layer. So we want to share all the UI components, and we also want to share all the resources. And typically the resources, if we're using Android, it's r.something, but the r class only exists on Android, so we need to give support for native to not use the R class, but to use a specific version or a specific generation of the R class. So let's see how to do everything. Before we start, I just want to show you a sample that I've built for this application. So let's see if the gods of live demos will work. So I've built here an application that basically what it does is going to fetch images from Unsplash, from the popular site Unsplash. So it's quite easy to navigate. I've got here a navigation. I can search for something, and that's it. And this is an Android application. This code, this UI code that's inside of this folder, that I realize now that you need glasses to see. So I'm just going to quickly increase here the font. Okay, so if you can see here, all this code that you saw, it's inside this shared UI folder. So all my composables are going to be here inside this folder called common main. And what's happened here is that I'm going to have my desktop application, I'm going to have my web application, and pretty cool because now we have support for this resize. Okay, so if the window resizes, it will automatically switch where the navigation should be. And pretty cool, now I have got Xcode here, and I've got my app running on an iPad, and I've got my app running on an iPhone. And the iPhone, it's with a dark theme on, and the tablet is with the light theme on. And you can see that in one case, I've got the navigation bar on the bottom, and in the other one, I've got it on the left. And I didn't need to do anything, okay? This is done by using the new navigation library that was launched for Android, for Kotlin multi-platform, and a set of libraries already built for Compose multi-platform. So if we see here, I'm just going to use the adaptive layout, the view model, and in this case, this is for image loading. So this is pretty cool because once again, I've got the code that I've built for Android. With small things, I made it run on the desktop, and with some other changes, I made it run on iOS, and I've got access to the same features. Also, JetBrains is putting a lot of effort here, and when you try to use the iOS application, you start to find it really similar to the native look. They improved a lot the scroll, that if you scroll your iPhone app built with Compose or your iPhone app built with SwiftUI, there are almost no difference when you're scrolling through a list. And if you check this repository, I have the same app built with SwiftUI, so feel free to check if things look alike or not. So what can be shared? Let's resume this part. So the goal here is we're going to share it across everywhere, okay? Of course, you don't need to share it with WASM, for instance, for WebAssembly, but you can also share it because this is done almost for free for you. So let's start by sharing our Compose elements. So if you're familiar with Compose, or if you're not familiar with Compose, if you want to add text on the screen, you call the text composable. If you want to display an image, you call the image composable. If you want to have a list, you don't call recycler view, you now call lazy column. If you want a horizontal list, you call lazy row, and so on. All of these components are part of Compose, and you use them to build your UIs. So let's see an example. Here it's the structure of my project. So in this case, I've got Android app, the shared logic, and the iOS app using Compose, the desktop app, and WebAssembly. And now I'm going to add a new folder. So I'm going to add a new multi-platform project model. It's going to be called shared UI. And what we're going to have inside of this shared UI, it's once again the targets that I'm using. So you've got your common main here, that this common main contains all your logic, and every time that you want something specific, you add it on Android main, iOS main, desktop main, and WASM. For instance, we're going to see an example that I want to format data, so I want to convert a string to a specific format, and you're going to see how we can do this at the platform level, meaning at Android main, desktop main, iOS main, and so on. So let's dive in common main. What we're going to have inside of this common main, it's all of your composables. So the code that you typically have inside of your Android app, you're going to have all of that code inside of your common main. So in this screen, that it's the about screen, I've got a text. You're going to call the text composable. Spoiler, you're going to see res.string. We're going to cover that later on today, but typically you just need to call your composable for the text. This text is in the middle of the screen, so I'm using a column just to center this text in the middle of the screen. It's the exact same code that you're going to run on Android, you're going to have inside of this common main. Next, this is valid for all type of composables. If we go to something a bit more complex, like the text field, in this case I'm using the outline text field, and this text field is when I click on it, it opens the keyboard and allows me to enter text. So if you want to have this composable shared, you just once again need to have it on your common main model, okay? Once again, all of your code, instead of being on your Android app, it's on your common main. All of your composable, all the calls, you've got them here. Next, there's a question, okay? Usually when we have an image that we're going to fetch from the web, we're going to use a specific library for this. You might use Glide, Picasso, Coil, and so on. If you want to do this multi-platform side, you can use Coil 3. Coil 3 has this support, or you can use Compose Image Loader by KDSFHDV. I'm going to use this Compose Image Loader. My main reason why I'm using it, it's because it was the first library, and it was also the first library that gives support to WASM. Okay, there's no big reason behind it. It was the first one, and is keep developing for multi-platform, and yeah, since it was one of the first one and it worked, I'm still using it. Of course, you can also use Coil, you just need to use the version number 3. this is fairly similar to what you do usually with Compose. So the difference here is that you're going to use Remember Image Painter from the library itself. So I'm going to make the import from SQL Image Loader, and then I'm going to use the composable from the Compose library and say that the painter is the one that I have on top. So it's the exact same code. What changes here is the import. Or if you use Coil, for instance, it's going to be the same code that you're familiar with. Now we reach a big question here about navigation and about view models. So the first library that I used was called Precompose, and I think it's worth mentioning a bit more because this user here, Talster, he was the first one to give the support for live data, for navigation, for view models. And this has been my main library for multi-platform development for quite some time, especially because he really liked what he was doing and he answered all my questions, he solved all my issues, so he has a special place on my heart for him. However, we keep seeing new developments, and now with the releases from Google, I've made the switch to use the Google version or the JetBrains by Google versions and moved a bit away from Precompose. There are, of course, other libraries that you can use. You've got Decompose, we've got Voyager, but currently my advice is to use the navigation suite and to use ViewModel by JetBrains/Google. How can you do this? This is quite simple. You're going to add these two dependencies, and an important thing here on dependency is this is inside of your build.gradle file, and you can see that I'm adding that on common main. I'm adding that on common main because they're going to be used by all the platforms. If there was something that I was going to use only on Android, I would use it on Android main, and only the code inside the Android main folder would have access to those libraries. So now if I want to add some navigation, and remember that we have support for the navigation on the bottom and on the left using the navigation rail, all for free. What I needed to do was to define the items that I want to show, a list here, and then I can just use the navigation suite scaffold. I'm going to iterate with my list of items. I'm going to add an item, and basically adding an item here is just adding an icon and adding the text of that icon and saying what will happen when the user clicks in one of these buttons. So if the user clicks, I'm going to update a remember variable, and I'm going to say that the new destination now it's going to be when the user clicks. When this changes, I'm going to load home content, which is the first screen, or to load the second one. And with these 50 lines or so, you've got all the support that you saw. So you've got all the support for having everything on portrait here on the bottom or on landscape here. And this even on iPhone or iPad. So next, what about platform specific? Once again, we take advantage of Kotlin multi-platform, and the example that I was mentioning was, imagine that we've got a string that's going to be a date, and you want to format according to, just want to show the time or something like that. So we're going to start by defining expect, okay? Because this code is going to be on common main, and we want someone to define what it is. And we're going to use the Java version for this. And since we're going to use the Java version, we need to have this code only on Android and on desktop, okay? And with this, we have access to the entire Java SDK. Similarly as you would have on Android. And we can just call date and then simple date format to format this date. Next, if we want to do things natively, we can just call the foundation. So a bit similar to what you do with iOS, you can just call directly NSDate, NSDate formatter, and you can format your date on native as you do on iOS development. Of course, using a language that we all love, which is Kotlin. So everyone. Is there any iOS developer here? Okay. We also love you. What about resources? This is the most tricky part. So when you talk about resources, also it's worth mentioning that there is a library called the Mocha Resources. Mocha Resources was also my main library until a few months ago. They nowadays are once again active, so they released the version last month, if I'm not mistaken. But the library started to have a lot of tasks to copy assets for iOS, so I recently updated all my projects to use Compose resources from JetBrains, and I've been really happy with the result because it has been working almost since day one. So my advice here, if you want to share resources, use the Compose resources version by JetBrains. So what happens here is we're going to our project structure again. We open common main, and now we're going to have a different folder there called Compose Resources. So basically, this is your res folder that you have on Android, but since it's going to be shared, it needs to be called Compose Resources here. And here, now you're going to have the structure that you're already familiar with, and you can have your drawable folder, your font, your values, and so on. So you can just almost move your files from res folder here to Compose Resources. So let's see how we can use strings. So you're going to use the same string files that you have on Android. So you've got your string XML file, and you can just use it inside of your project. In this case, you're still using string resource, but in this case, instead of using the Compose version, you're going to use the version from JetBrains. Okay? So here, you're going just to replace the import, and you're going to have access to this specific function. Also, you saw this before, but instead of using the R class, now with Compose Resources, it's going to generate a res class. And this res class is what's going to allow you to have your strings on Android, iOS, on the desktop, on the web, and so on. Also worth mentioning that it's string, not strings. This is something that I've yet failed to learn, because every time that I'm using this, I still write strings, but it's string. Don't really know why. If you want to load a font, it's quite similar. So you just need to have a font on that folder, and you can just load the font. However, this font family function is a composable one, so you need to declare it directly on the text. You can't declare it on the typography as you usually do. So you need to declare it every time that you want to use it on a text. My answer to you is just create a composable text that loads that font, and instead of calling the native one, just call your own text. Finally, talking about images, you're going to load once again images. The difference is you're going to use Painter resource from Compose Resources instead of using the one directly from Compose. Once again, you're going to access the res generated file and not the R class. So how to call your shared UI code, and this is just to sum up everything. So what I usually do is, in this case, I've got a view model, and I want to set my theme and prepare everything. So I create a composable that I usually call app, and I put all of this initialization inside it. This is still inside common main, and this is going to be the entry point for my app. And what I'm going to do now is I'm going to go to Android. I'm going to go to Android, and when the Android opens, it's going to call the one created, you all know. And inside of the set content, I'm just going to call app. And it's going to load everything that I've got on my shared UI. Now, if I move to desktop, in this case, there is a main.kt file that's going to be called with a main function inside. So what you need to do is you call application, you define how the window should be, so the size of the window, the size, and the title, and you call, once again, your app function. If you go for iOS, here it's a small difference. You've got this code is on Swift UI, so you've got your content view.swift, and what you're going to do is create a function inside of your iOS folder, and the function is going to be called Compose UI View Controller, and there you called app. And what you do on your content.swift, so on your Swift UI, you just need to call the main view controller from the function that you've created. So this is, I'm seeing your faces. So I'm just going to show you pretty fast. So what you do here is you create a file called main view controller, and you just call the Compose UI View Controller and call your app. And this code here is called from Swift. So you've got access to the code that you've created on Compose. And with this single line of code, you've got access to the entire app that you've built. Easy, right? Be careful with the demo effect. Don't forget it. On WebAssembly, once again, it's fairly similar. So you've got the main function, and here you call the canvas-based window, where you define the title, you define the canvas element ID. So you're going to have an index.html that you need to say where that your code should be loaded. So this is the ID that you have there, and automatically it will load inside of it. So what's missing? So there are, of course, this is still under development. iOS, in this case, is on beta. WASM is on alpha, if I'm not mistaken. From my point of view, there's still low accessibility support. So if you want to give support on native, there's still some things that need to be improved from JetBrains' side. The Cooper team is still work in progress. We've been seeing on the latest releases a lot of development, but there are still small things that need to be done. There is no support for Apple Watch that I'm aware of. So if you want to share your code with the watch, it's not yet possible. It will be in the future, but not yet. And yeah, it's still on beta. Once again, there are apps in production using it, but it's still beta. About WASM, we're starting now. So we see that we can have a site working. But once again, this is a simple example. The size of the site, it's not that comfortable, so it's bigger than it should be. But in any case, it's good for a proof of concept and to have a platform for free. And it's still on alpha. Why should you do it? The reason why I switched to Compose multi-platform is, I don't know if you're aware of this, but not everyone has an Android phone. Yeah, I didn't understand also why, but there are people with iPhones. But those people with iPhones really love the Android work and wanted to test what I was doing on Android. So I basically give support for desktop for the Android app. And with this, they could test the Android app running on desktop. It wasn't my smartest idea because they could also create issues for bugs that I have on the Android app. But the cool thing is that quite easily, I think it took me 1 week, 2 weeks, to give this support to desktop. They could easily use the app. And also, this means for my company that they were able to sell this app. Like I've spent months working it when I could just easily port it to Android, to desktop. Also, new platforms are the way to be supported. Usually, people go for Compose multi-platform when they have the Android app and not yet iOS app. But it's also valid for if you have an iOS app, but you've got more Android developers and you want to easily ship more features faster. So, some key takeaways, really simple. This is my opinion about the current state of multi-platform, so I'm giving 5 stars for everything. Kotlin multi-platform is you reach a point of stability where you can use it in production without any problem or any big problem, let's say. Once again, JetBrains answers really fast on the Kotlin Slack, so if you have any question, you can go there and typically in a day you've got an answer, sometimes in hours. There are a lot of libraries out there, they're really good support. And about Compose multi-platform, I'm going to give it 5 stars for both Android and desktop. Native, since it's not yet stable, there are small things that aren't yet there, but they're really doing a good job and you can start having your apps on iOS. WASM, WebAssembly, we're starting it, and yeah, Safari announced the support for WebAssembly, so things are also moving towards it from the browser side. So I've got all the links here. You can just scan this QR code and you've got access for everything. Thank you so much. I don't know if we have time for questions. No? No. Okay, so I'm going to be here. If you have any questions, feel free to reach me. And thank you so much for being here and see you around. Thank you. guys have control over it. And then use my turn, and I'll just come back and English language.
Do we need to do? Oh. Yeah. Okay, well.
It's all right. Hello? Yeah. Thank you. Hello, everyone. Thank you for joining us. My name is João. I'm a senior technical manager at Viator, where I lead the mobile engineering teams.
Hey, Droidcon Lisbon. I'm Adam Law, senior software engineer at Viator, iOS lead, and head up the platform team on mobile.
Hi, I'm Ricardo. I'm senior mobile engineer and also tech lead for the Android Lisbon platform. All right, so if you're not familiar with Viator, we are a market leader in travel experiences with over 300,000 experiences for you to explore in our app. You can find everything from tour guides to extreme adventures. Actually, if you're staying the weekend in Lisbon, we have quite a lot of products in Lisbon, so if you're looking for something exciting to do, feel free to use our app. I lead dedicated teams that work on mobile development with over 20 people, most of them software developers, Android and iOS, and distributed across 7 countries in Europe, also here in Portugal. We have an office here, and some of our engineers are based here in Portugal. We've been, for the last 3 years, developing the Viator mobile app based on native technology, so on Android and on iOS, and using a fairly modern tech stack. So, for example, on Android, with Kotlin, coroutines, Jetpack Compose, powered by a GraphQL backend. So recently, we started to look into expanding mobile engineering into other already existing multifunctional product development teams that were doing mostly web and backend. And with that in mind, we are now starting to shift focus of these dedicated mobile teams from product development into platform development. So what do I mean with platform exactly? I'll leave that for you guys to read. I won't read through all of it. There's a QR code that takes you to an article where that definition was coined. I think it's a very good definition. But taking some key aspects of this definition, so if you think about this set of tools that are organized as a product, that will help other engineering teams to self-serve and deliver at a higher pace, you probably realize that, in a way, we are already doing that. Probably you guys are already doing that in a way or another, because we inevitably have to build the tools in our code base to support the feature development that we need to do. So, but if you think about it, like, are we really building platform in a way that others can self-service, in a way that we remove low-level knowledge from the engineers that are building product features? We remove cognitive load. These platform tools are actually empowering, helping, enabling these other teams, these other developers, to move faster, to build better products. And the answer, at least for us, was, well, kind of, but not really. So that's when we started looking at this concept of platform as a product, with the goal to solve those problems and actually become more efficient. Any product needs customers. So who are the customers for this platform that we want to build? I kind of gave that away. That would be other product engineering teams that are focusing on building the user-facing features. I mean, primarily because you could look for other internal and external customers for this platform. Especially if you are in a part of a bigger group like we are at TripAdvisor, there's other mobile teams, so there would be opportunities there to find other customers. But for the sake of time, we'll just focus on these other product engineering teams. So we are building native applications on Android and iOS. And that means that if you're going to build platform as a product, it needs to be consumed by both platforms. So that means that you're actually building twice the same product, Android and on iOS, different code bases, different tech stacks. So more expensive, takes longer, more complex, not ideal. And that's when we started also looking at Kotlin multi-platform. Because we're not trying to rebuild our app from the ground up with multi-platform technologies. We're trying to build our platform with multi-platform technologies so we can just maintain one code base and have these tools be consumed by Android and iOS alike. So we are at the very early stages of this journey, and we would like to share that journey with you guys. Hopefully, through this session, you'll learn about the challenges we faced, the mistakes we made, so you don't have to. Adam?
Thanks, Joe. So, yeah, why did we choose Kotlin multi-platform? There's a ton of cross-platform frameworks that we could have chosen. Too many to kind of go into for this talk, and it's not the topic of this talk anyway. But I just wanted to cover some of the main reasons why we thought Kotlin multi-platform was a good fit for us. So, yeah, the first one is that your apps remain native. So we already have native apps. We don't really want to depart from having native apps. So all the app code remains native. So Kotlin JVM compiles down to Java bytecode that runs in the JVM, unsurprisingly. But iOS doesn't have a JVM. So Kotlin native compiles down to a native binary on iOS. And the practical upshot of that is there is no performance trade-off. It's not like this is native, but there's a JavaScript bridge which you're going to get caught out on with performance. So, you know, the Viator app is fair to say it's not a performance-critical app in the way that it's like a game is. But we didn't want this sort of venture into a cross-platform to come any detriment to the user experience. And so, obviously, performance is a big one there. So any cross-platform framework in the grand scheme of things is kind of a high-risk investment. It changes the way that we go about writing code and obviously sharing that code. But in the grand scheme of things, Kotlin multi-platform presents a low risk because it's not an all-or-nothing approach. You can go in and you can share the smallest amount of code, and you can prove that out, gain confidence in it, and then you can go on to share bigger things. So in our particular use case, we wanted to keep the UI native. We love Swift UI, Jetpack Compose, and well, at least in the case of iOS, we didn't want to depart from Swift UI. So we decided to keep the UI layer at where it was, and we looked at other areas that we could share code. And then another big thing, of course, it doesn't require an app rewrite. And in the case of the projects that we've got, the two established projects, we've got a mature Android code base, which in many cases, we can take the Android code and we can rework that into KM with like little to no change. So that's a huge win for us as well. Language interop. Yeah, so I mean, obviously, KMM just works seamlessly on Android, unsurprisingly. But even on iOS, the interop with Swift is pretty fluid. It works well. It does use Objective-C as a bridge. So some of the Kotlin language features do get lost. But there are sort of ways around that, and one of those is a Sky compiler plugin, which really kind of improves things there. We'll touch on that a bit later. But in addition to that, technically there's no reason why there couldn't be a direct interop with Swift. It didn't make sense to do it at the time, because the Swift ABI was not stable, so it would have been a world of pain for JetBrains to do that direct interop off the bat. But it's something that they said that they're going to be working on. So that's going to really improve this area even further. And then, yeah, familiarity. So obviously, Kotlin's super familiar with all of the Android developers. It's a language that they obviously specialize in and able to offer support with for iOS developers kind of wanting to get into this. But also as a language as well, it presents like a less of a learning curve for iOS developers because it is quite comparable to Kotlin in many ways. And then finally, developer satisfaction. So it was like 98+% satisfaction score from like a 2001 survey that I think JetBrains did. And it's evolved massively since 2001. So the future for Kotlin multi-platform is really vibrant right now. And obviously this year at Google I/O we're seeing Google now supporting it as a first-class citizen. So we're going to see Kotlin native support turning up in more and more Android APIs going forward. And I think on yesterday's talk, John O'Reilly, you saw the number of libraries that are available in Kotlin multi-platform. So it's a good time to sort of jump in and take the plunge. So with that, I'd like to hand over to Ricardo to summarize our journey so far.
Thank you. Okay, about our journey. So we start when thinking, when can we share our code? Because one of the patterns we start to notice is in both platforms we have the same code and logic, especially when, for example, we are fetching data, and it's like we are when reading the code twice. And with these photos, maybe we can create a proof of concept. So we select KMM. Maybe we can learn a bit about this platform and how it behaves. And after, maybe we can rework an existing feature. So we select the logging. Logging is the simpler feature when we have. The logic is simple, it's easy to use, also it's safe. And we can even reuse the code what we have on Android, so was a good candidate. But this implied now we have a third project. So now besides the iOS, Android, and now it's a third one we need to start managing. And after this step, we start rolling out in production to see if it's safe for production. This was behind of a feature flag. In case something goes wrong, we can always disable and replace for the old one. And also see if there is any impact on the app open binary. Our sample was like a few kilobytes, so it wasn't a big deal. After this, we start looking. We need to take the decision: should we use it? And we need to look for, need to evaluate what was the challenge, especially the challenge. It's where we want to talk a bit more. Nothing is perfect, and we found some challenge for both platforms, especially for iOS, and this is where we want to share our perspective as another developer, what you can expect when you try to use KMM for both platforms. Adam?
Thanks, Ricardo. Yeah, so the first thing I wanted to talk about was CI/CD. So the out-of-the-box behavior when compiling Kotlin multi-platform is you can get an Xcode framework locally, but that's kind of where it ends. So obviously, if you want to take this into production, you want this going through CI/CD, a proper pipeline. So we decided at an early stage to adopt Cambridge. It's a Gradle plugin from the guys at TouchLab. And yeah, the big kind of benefit that that offers is that it handles a lot of the iOS publication, so supports CocoaPods and SPM. Because the SPM publishing is quite tricky, the setup of Cambridge is also quite fiddly too. So fortunately, they provide a template project with all of that configuration set up. So it offers like a really quick way to kind of bootstrap your project and get that working through CI. So in addition, that template project provides a couple of GitHub publish actions. So a publish action for iOS, and then a publish action that publishes both iOS and Android. So yeah, we use those publish actions, and then on top of that, we added a basic pull request workflow that just runs the full suite of unit tests and acts as a gate for mergers. So we got all of this set up, yeah, pretty smoothly. The only slight thing for us was that we use GitLab, and all of this is set up for GitHub. We didn't want to kind of invest a ton of time at this stage kind of reworking that into GitLab. We wanted to spend the time instead on the actual project and what the integration looked like back in the respective projects. So as a short-term thing, we just set up a free GitHub tier account internally, private, and we used that. And all was good. We got the first version of the library kind of in a state where we were happy to integrate that back into the projects. So we did some workshops with all of the development team, because there's a bit of project, like one-off project setup that you need to do. We went through that, and we got the library integrated back into both apps. So yeah, happy days, all good. And that's kind of like roughly the time when I packed my bags and I went on holiday. But, there is a but. Shortly after I left, all of the builds in CI started failing. So both iOS and Android builds. This is a snapshot of one of the failed Android builds. Artifact not found exception, which is funny because the artifact hadn't gone anywhere. It's slightly misleading, but turns out that this was a usage quota issue. So yeah, we hit the free tier usage quota on GitHub packages, which is kind of unfortunate, but yeah, it's not super clear from that exception what it is. On reflection, I kind of think like, if you left the house in the morning and you'd forgot to pay the mortgage, when you come back home, would you find that your house has miraculously disappeared and there's just a void of land? Probably not. So yeah, there's probably a more useful message that the guys designing that API could give for that. But like the short-term solution that we took here was just to move the artifact to Artifactory. But it worked. So we manually deployed in the short term to just unblock the builds. And then, we took the opportunity at that point to do the migration to GitLab, which we'd kind of always planned to do anyway. The support for GitLab with Cambridge, they'd recently added some publishing support. We were using GitLab on-premise, which it didn't support, but we've added support, and we submitted a merge request, and that's gone back into the library now. So yeah, long story short, we just have everything migrated to GitLab now. And yeah, I guess the learnings from this are, well, if you use GitHub already, it's a no-brainer. Just use those actions, at least initially. But even if you don't, you can set up a free tier account, and you get a Mac runner for free as well, so you're not burning any CI time if that's precious to you. whilst you're in these early phases. But if you do that, obviously just, take a look at your usage to make sure you don't have any unexpected surprises. So on the topic of boom and bang, I'd like to hand over to Ricardo to discuss crash reporting.
Okay, about crash reporting. Well, one of the challenges we found, especially for iOS, it's the stack trace. So in case if there is a crash inside of the KMM library, you just see this Conan abort, and that's it. For iOS developer, you don't have any kind of context. So to simplify this, we are using this one library. It's called crash bootcamp in iOS. What it's doing, it's symbolic representation of the exception. So in this case, this is like you can see on the Crashlytics, you have all the information of the Kotlin class inside of iOS. This helps a lot, especially for iOS developers. Android doesn't have this issue because it's this behaves like a normal dependency what we see on Android app. And this Crash KiOS supports Bugsnag and also Crashlytics, but still needs to be initialized on the client side to work. Error handling and propagation. So this was found by accident. We are using this library. It's called Sky. KMM only expose Kotlin to Objective-C, but this one Sky allows to convert Kotlin to Swift directly. It supports Mozilla class, enums, suspend functions, and also flows. This is a small example. Flow done in coroutines can be exposed as a Swift combined easily, so it's easy to use. For our surprise, this Sky doesn't propagate the exception. So for some reason, exception is thrown inside of KMM one library. Okay, let's wrap with a try catch inside of the iOS side. This is a small example of what is happening, and for some reason, it doesn't catch anything. And we notice the app was always crashing because this exception is never propagates. One solution is to wrap the result the error state. But even Kotlin has the result class like Swift. The result class is a value class, and the value class is not supported by KMM. It can be exposed. So ideally, it's to wrap with your custom result class. Yep.
So on the topic of local iOS development, appreciate this is an Android conference, but obviously we do have to talk about some of the iOS things because the success or failure of any cross-platform thing lives and dies by like how well it integrates with all the platforms. We chose a remote published workflow, so traditional workflow. So we build features into the library and then publish those remotely and then consume that back into both projects. And there's a few kind of good reasons why we did that. Firstly, Cambridge provides a remote workflow out the box. Android can still consume a binary locally, or you can even publish to Maven local if you need to. But importantly, like iOS can consume the library just like it would any other dependency. So it looks just like any other dependency. And we use the Swift Package Manager to do that. And then also, iOS developers aren't forced to have to jump into Android tooling, so they don't have to pick up Android Studio to like compile the code and then embed it or anything crazy like that. But there are a couple of like downsides with that approach. So the remote workflow can be a bit slower because you kind of got to make the changes, publish them, version them, integrate them back, and then if you find out something's not quite right, you've got to go back around the cycle again. And then, iOS developers have got to go to a separate repository to make those changes, which I think in the scheme of things is kind of acceptable anyway, because that's sort of inevitable. With any, cross-platform approach, it's inevitable you're going to have another repository. It makes sense. So, one of the obvious questions that comes up from this then, from the kind of iOS perspective, is, I want to make some changes to the library, but I don't want to have to publish them, integrate them back, just to find out they didn't quite kind of work as I was anticipating. So, is there a local development workflow that can be done on iOS as well? And yes, there is. It's not super straightforward. There's a bit of black magic to it. But just before that, obviously, we should be covering the code in unit tests anyway. So, the unit tests should give us a good baseline confidence in the code that we're writing is behaving as expected. But then, in addition to that, in the KMM project, we added demo apps for iOS and Android. So you can run up those demo apps, and you can see the library kind of integrated back into a sample project with a bit of UI. So that's great for just obviously demonstrating the functionality of the library, but it's also good for kind of teasing out any potential integration issues with the library back into a skeleton project. But there are times still when ideally we need that same local development approach on iOS. Unfortunately, Cambridge provides a workflow for that. So it's basically a Gradle task you can run, SPM dev build. That builds the project in debug, and it updates the Swift, the package.swift file for iOS to point to your local directory. And then with kind of some slightly strange, got to drag it into Xcode, and it replaces the remote with the local, which it kind of does by itself when you drag it in. Once you've done that, you can build the iOS project, and you're running from a locally built library, which is great. The only slight snag is when it comes to debugging, there's no debug support. You can't set a breakpoint, can't step, can't see variable information. So fortunately, Touch Labs have also produced an Xcode Kotlin plugin. It's got a CLI aspect to it, which basically downloads the plugin, and you can run it when you get a new version of Xcode to kind of reintegrate it, and it keeps the plugin up to date. But essentially, this plugin gives you the Holy Grail, which is full debug information. So just a screenshot there, you can see the full call stack, set a breakpoint, line stepping, all of the variable information. So yeah, this is debugging, and you can even change the Kotlin code in Xcode. So this is a bit of a game changer. It makes a huge difference. And so that's where we've kind of left things in terms of the approach that we have on iOS. It is, however, worth mentioning because this whole area is moving so damn fast. Only a month or so ago, Touch Lab produced a Git portal tool, which actually instead of publishing the library in a traditional sense, you don't publish it at all anymore. It kind of acts as a Git submodule, and you pull back a versioned code back into both projects, and then you can skip this entire local dev workflow step on iOS. So it makes the experience even slicker. The tool's only in alpha. We're going to certainly be keeping an eye on it over the coming months. But for anyone kind of approaching this now, I definitely recommend that you check that out. Back to Ricardo to discuss Apollo.
Apollo, it's a GraphQL client. It's now when they are also supporting OneKMM. It's powered by OneKeyTor, and Apollo provides its own caching mechanism. It can be memory or SQLite database. And this is also powered by SQLite. And we found some linker errors because on iOS especially, some functions were not defined. And this was surprising because what we noticed is SQLite is supported by Android natively, but not for iOS. iOS needs this SQLite 1.3.h as a source file. And since this is external source, needs to be linked on the build phase during the next code. Apollo can link this automatically, but there is a small caveat we found. This only works if it's a project. But if it's a package on for Swift, it's the same thing like we have as a dependency, and we need to specify on this package.swift is the same is the metadata for the package, and we need to it has all information about this dependency, and we need to specify especially needs to link SQLite 3. Or the Xcode doesn't know this package as another framework inside, in this case, for Apollo SQLite. So it can't work.
So one of the kind of more recent issues that we ran into, so we had a bit of shared states. And we had an issue on iOS, basically. We were consuming some code in a slightly different way to how we were on Android. And we were consuming it in like an asynchronous context. So we had a race condition. We needed to basically shore up that code. So it was guarded against that. So, if this was in a coroutine, then, we could use the Mutex APIs to delimit that section and suspend the coroutine. And I know the coroutine support in Kotlin Native has come on a lot since the new memory model. I think coroutines now run on multiple threads instead of a single. If you're using coroutines, you're in a good place. But in this case, we weren't using a coroutine, and we wanted, we needed to do like a traditional block. So couldn't use synchronize because that's part of the JVM, so not available on Kotlin Native. So there's a couple of kind of options there. So a couple of third-party libraries. I mean, I say third-party. The first one, Atomic Foo, is actually a JetBrains library. And the second is a TouchLab one. They basically provide concurrency primitives and collections. We use the Stately library because it's just kind of a lot simpler, a lot smaller, and it kind of fit our needs. And just kind of an example here using the Stately library. You can inherit from synchronizable, and then you have access to the synchronized functions, which you can use to wrap the critical sections. So the code looks really quite kind of similar to how it would if you were just writing Kotlin on Android.
And our final challenge was the minimum iOS version. So in this case, it was for our surprise when we tried to publish our iOS app on the App Store using one with the KMM library, the app was rejected. And the reason was is the Monero framework for iOS needs to have the minimum iOS version specified on the file info 1p list. This is also behaves like a metadata for a dependency, and so in this case, on the KMM project, we need to specify on the compiler arguments to write the min version for iOS. So when on the build time from the KMM, we can show, you can see this, and after this, we're able to publish it on the app, not any issue. Sure.
So then just to wrap up, so yeah, next steps for us then. So yeah, the iOS developer experience remains a key thing. I think we've got to a point where it's as good as it can be for now, but there are improvements that could be made there. Perhaps with the use of this Git portal tool, we can kind of take that a step further. So we've got our first module in production now. So we refactored all of the logging module into KMM, so that handles all the development logging from standard out to kind of in-memory logs when developing. And that also takes care of all the crash reporting as well through Crashlytics. We've got a new use case for logging. We've got an in-house platform for remote logging. So we're going to write a remote log writer, and we're going to plug that in using Amazon's Elk stack. So we've got some interesting work coming up there. But obviously, yeah, we want to get to work on our first new module built with KMM from the ground up, and we've started work on that already, got quite far into it. So we use Firebase for A/B testing. Everything that we do, we A/B test. And we've kind of outgrown that now. And we've got an in-house solution for A/B testing that is going to allow us to run A/B tests from web across to mobile. So it's going to kind of relieve some of the issues that we have with kind of being confined to Firebase. So yeah, we're going to add a Viator experiments module, and we're going to build that in KMM from the outset. And I think, you know, once we've delivered that, then that is kind of marks a good point to kind of take stock, look at what the benefits are, gauge kind of developer sentiment, and really kind of see, like, you know, is this stacking up to what we thought it would be? Are the development savings kind of what they are? You know, how does everyone kind of feel about, like, the development flow as it now stands? But ultimately, kind of unsurprisingly, yeah, aspiration is to refactor loads more things. We've got a ton of use cases, from like utility things like analytics through to like networking and the data layer. We've got like we're following clean architecture in the project, so it makes it quite nice to be able to kind of draw a line and decide like what you want to essentially bring into KMM. So that's where we're headed next. Got some interesting work ahead of us. Over to Zhao for some closing thoughts.
I'll move to that side. It's okay. You guys can stay. Thank you, Ricardo. Thank you, Adam. So, if you find this concept of platform as a product and developed in Kotlin multi-platform interested, and if you'd like to join us on that journey, we'll soon be hiring for multiple positions on mobile development, both on Android and on multi-platform. So keep an eye on our careers website, or if you follow that QR code, there's like a simple form where you can leave your interest, your contact, and we'll get back to you. So wrapping up, if at any moment you had the impression that we attended the wrong conference just because of all these references to iOS, we didn't. If you look at this conference alone, just the number of sessions that touch Kotlin multi-platform, the fact that you guys are here shows that the community has quite some interest in developing multi-platform using Kotlin. And you guys, as talented Android developers with Kotlin experience, will be the more likely candidates to take on that task. And what we learned through this journey thus far is that you guys will find no challenges or very little challenges building your platform with Kotlin multi-platform and running it on Android, something that you're familiar with. However, if you're trying to build multi-platform, chances are that you want to build it for other platforms as well, like iOS, and that's where we found that everything that you learned today. So in that sense, if, like us, you're trying to solve the same problem, and you have a similar setup, you have Android engineers, iOS engineers on your teams, just bear in mind that there will be these challenges. Do involve the iOS engineers building multi-platform, and roll up your sleeves and help them overcoming those challenges. If you guys have any questions, any comments, or if you want to catch up with us, we'll be around all day. And we're easy to spot by the matching t-shirts. So yeah, we would love to talk with you. Yeah, just approach us and we'll get to know you. Thank you, everyone.
Yes, presenter note is there in the slides here.
That one does exactly the same thing as the front one. Those are mirrors.
So there is no...
You cannot separate those, only these compared to those. If you want, you can put your notes here and project there. But
okay.
You'll have to duplicate and not mirror.
Okay.
How long will I slide or separate my side? I don't believe it's been slitting my throat is all I have. I heard your voice through a photograph. I thought that I've been brought up the past. Once you know you can never go back, I gotta take it on the other side.
Hi, I'm Marcelo. I work in the Android X architecture components team at Google, and today we'll be discussing the commonization of the lifecycle libraries. Before we start, just a heads up that this talk is designed for library authors. So if you do develop a library and you want to migrate this library from Java or Kotlin to Kotlin multi-platform, that you might learn from the same challenge we faced. If you're an app developer, you might not be able to use all of these things in your app development life. However, it might still be interesting for you to know what was the challenge, why we did things the way we did, and the reasoning behind that. So for today, first we will be talking about the Android support for Kotlin multi-platform that has been announced in Google I/O 2024. Second, we will be discussing the timeline to get the lifecycle libraries released to stable. And finally, we will be talking about the API challenges. This is going to be the longest part of the talk, and it's going to be mostly code. We'll be discussing a bit of the lifecycle and also the view model APIs. So in 2017, we introduced the architecture component libraries, and with them also the view model and the lifecycle libraries. Also this time we had mostly Java first ecosystem, and these libraries were designed for this ecosystem. We still were using the XML View UI toolkit that if you have been doing Android for a while, you are probably familiar with. Fast forward to 2024, we did announce that we are officially supporting Kotlin multi-platform. The word now is a bit different from it used to be. We do have a Kotlin first ecosystem mostly, and we also have the modern UI toolkit Compose. So what does it mean to support Kotlin multi-platform on Android? There are basically two types of support, the compatibility and the support in itself. For the compatibility, the idea is basically that we are converting libraries that can be used in a Kotlin multi-platform project. You can basically include this project in your Gradle file, and you can call this code from your common source set, but you might need to provide integration by yourself. That means you might need to write your own lifecycle owner, or you might need to use a third-party library such as Navigation Compose multi-platform provided by JetBrains. For the KMP support level in itself, that is mostly, it's like KMP compatibility, but there is already out of work, it basically works out of the box. So you can just drop in the project, you don't need to provide any type of integration, and things will just effectively work. Example of a library that has KMP support is room. You can put it in a project, and as long as room support the target, you can use this library without any additional work. So let's talk a bit about actually the timeline to get the life cycle, these libraries to stable release. The main goal was to get the navigation KMP released. And for that, we have mostly been collaborating with JetBrains. They have been very willing to get official navigation support for Kotlin multi-platform. And how we basically divide this work is that we start to collaborate with them in January. The whole work went from January to May in 2004. And we start to have syncs with them, try to understand what would be the roadblocks, and we start to remove these roadblocks so they could actually work in the navigation KMP. Basically, what we did is we mapped the dependence from the navigation libraries. And those are most lifecycle, runtime, common, compose KMP, view model, and these things, save state, and so on. And we at Google, we start to work in making them stable and converted to KMP ahead of time, so that JetBrains could focus actually in the navigation library. For us, it was very important to actually get the lifecycle released as a stable, mostly because we did want them to depend on stable APIs on the navigation. So once they had their first alpha navigation release, we want them to be building against a stable lifecycle common API, so they have a guarantee that those APIs are going to be supported in the long run. So let's talk a bit about the challenge in itself. So if you have been doing Android for a bit, you might be familiar with the lifecycle events for an Android. You do have the on resume, on pause, and so on. As it seems, most of the other platforms have similar events. Those are basically mapped through callbacks. So if you're in an iOS platform, for example, you would be mapping something like view will appear to on start, or view will resign active to on pause. For desktop, that's also similar. We can use something like window gained focus to on resume, or window lost focus to on pause. For web, that's a bit different. Like web is much simpler lifecycle-wise. So mostly we map the focus to on resume, and when there is a blue, we go to on pause, and that's basically it. If you're using Navigation Compose multi-platform, if you're using Navigation Compose multi-platform, JetBrains automatically does this mapping for you. If you're not using that, you have to do the mapping yourself. So view model provider. So if you use activity and fragments in your project, you might be familiar with the by view models API, which basically allow you to pass in factory and return a view model. It's an extension function that lifecycle owners such as activity, fragment, and nav backstack entry have it. Composable, in case you are doing compose apps, you can use the composable function view model, and you can just return a lambda that's returned the view model. Pass in a lambda that returns the view model. And it returns the instance of the view model. And behind the scenes, all of them are, at some degree, there are other things happening, but in the end, they will all store a factory and an extra, and then calling the get, passing the key and the key class, or a Java class, in this case of the view model. They do also do some other things like keeping a reference, like to not have to access all the time, like lazy and so on, but in the end of the day, it's always going to the view model provider. The view model provider is basically the main API surface if you're using view models. So the view model provider class. This is a simplified version of the view model provider. If you open the Android X repo, it's going to be a bit more complicated than that and with more methods and so on. But here we do have a simplified variation of the methods that caused some of the issues that we're going to be covering. The first thing we will be discussing is the constructor. The constructor taking the view model store. The view model store is basically the class that when there is a configuration change, the view model store is going to be retained in memory. And when you ask for a new view model, the view model store is the one caching the view model and give you that back to you. The factory is an interface that allows you to create a view model. And the creation extra is basically additional arguments that you can pass in to configure the view model instance during creation. There is a get function that is the function that orchestrates all of that, takes in a key that is a string, a model class representing that view model, and always return a view model instance. There is a factor interface that is very similar to the get method, actually. Takes a model class, take a extra parameter, and then returns the view model. Here, the factory always creates a new instance of the view model, while the get may create a new instance of the view model, if there is not created yet. There are two different implementations for the factory interface. One is the new instance factor, which is the factory used to create instance of view model using the no-args constructor. And there is the Android view model factor, which is a specialization of the new instance factor that does the same, plus it also supports creating view models that have a single parameter that is the android.app.application. And the companion object that add utilities to the view model provider. So, the constructor. If we take a close look at that, we're going to see that there is a creation extra that by default is empty and is annotated with JVM overloads. The JVM overloads here is important to keep backward compatibility Java and interoperability for the default parameter. Theoretically, if the creation extra is already converted to KMP, we could potentially just move that to Android main to common main, and all of these things should work. The JVM overloads is supposed to work on KMP. It's going to affect only when you build for Android or JVM targets. And things should just work by moving it from Android main and common main. So what we can do in the Android X repo is we can actually run this command Gradle check API. And this is going to run MetaLava, and it's going to check the API to see if there is any unintended API change that we didn't want to cause. This command will check it on both JVM targets and native targets. So for native targets, if I remember correctly, we do use the Kotlin Bind validator from JetBrains. For JVM targets, we use MetaLava. So by running this command, after just moving the file without any additional change, we do get output that says that a constructor has been removed and a constructor has been added. Both of them have the same number of parameters, the view model store, factory, and creation extra. And yeah, if we do look closely, we can see that there was an optional keyword that was added in the last parameter, and this optional keyword stopped existing after we moved the file. So what we can do here basically is we need to figure out why this change happened. So we can take the code before moving and the code after moving. We can take the Java bytecode, we can decompile this bytecode, and we can compare the two of them doing a diff. If we do that, we're going to get this code. And basically the two functions here are what normally you would expect from the JVM overload annotated method. It basically takes the view model store factory or store factory plus default creation extra. So Java clients can call the two of them. The first variant, we can automatically pass the empty creation extra. What is interesting here is that there is a third method that the Kotlin compiler is going to create. And this is used, it seems, based on their issue tracker and documentation, for internal optimizations that the compiler can do. The thing here is that this method is actually public and is a syntactic method. Clients will not call that directly, but the compiler might optimize the code that your client is using to use this method. There is also the default constructor marker in the end that clients cannot access directly, but the compiler can. And as it seems, if you do move files or annotated class constructors from common main to Android main, annotated with JVM overload, the Kotlin compiler will not generate the syntactic method, default constructor marker, and that will be an API change. And basically, if you do have a client that compiled against the old version of view model, and you happen to run it against a new version, that method would not exist, and that would actually crash. So what we can do instead here is that we can fix that by ourselves by manually implementing what would happen here. So we wouldn't need to leave the view model, the constructor function as it is today for Java and Android compatibility. and we're going to introduce a new create method that does exactly the same, and just pass the call forward to the view model provider constructor. So it doesn't do any additional work. And basically here, new clients that use KMP code, they would need to call the view model provider calling the create function. Android clients would still work as it is. And everything that has been compiled previously will still work with any new version of Android view model. So the first learning from this is by just moving files from common to common from any other platform might change the public API. If you do not have any tooling that validates these APIs, you might have an intentional change that might break customers and clients. Ideally, you should have something integrated if a library author, such as the Kotlin JetBrains, Kotlin binary validator, I think that's the name, or MetaLava or something. So next, the get function. The get function is quite straightforward in the signature. Takes the string in the model class. And if we do check the model class, we're going to see that that is a java.lang.class, and that is only available for Java clients. We need to actually handle that. This function cannot be converted to KMP, but what we can do instead is we can duplicate this function. We can change the signature to take a key class, which is available on Kotlin with platform, and we can backforward the call from one to another to be sure that they are still compatible. If you're using the view model provider in a KMP common source set, you will be able to call the get function passing the key class. If you're using Android, you will still have Android or JVM. You will still have available the model class that takes the java.lang.class, and they are compatible. And by doing that, we actually start to receive reports that there has been some, basically there were people that had tests and these tests stopped to work. And the reason these tests stopped to work is that they were using mocks. And basically before we had one method that took in 2 parameters. But now we have an additional method that takes 2 parameters, but less parameters instead of a class is a key class. And mock libraries, normally they are not able to differentiate that by themselves, so they automatically assume that there is an ambiguity and there is no way to define which one you're actually mocking. And yeah, one way to fix that would be to explicitly define the any type in any, but in our case, our learning was to simply not use mocks. So now the factor. Yeah, the factor, like the example before, takes in the model class, a creation extra, and return the view model. We expand the class. We get the java.lang.class again. We need to do something similar. Different from before, the get function is actually a final function, and this is actually an open abstract function that you can implement yourself. So we do introduce a new method that takes in the key class, but now is the other way around. The new one actually called the previous one to be sure that the previous one, people that implemented the previous one, the code would still work as expected. And besides that, works exactly the same, and the throw is actually the re-implementation by default if you don't implement it. So the learning here is, if you do have platform types in your public API, such as Java in our case, migrate from Java to Kotlin platform, you really need to worry about maintaining backward compatibility, and you need to figure out which types we're going to replace that and how we're going to do that without breaking your customers. It might be that you have to duplicate methods. It might be that you can actually sunset some of the methods if they don't make that much sense anymore in your API, but there is a trade-off and you need to figure out by yourself. So the new instance factor. If we expand the new instance factor content, we're going to see that it basically called the model class .getDeclared constructor .new instance. The thing here is that this factor uses the noargs constructor to create instances of your model, and the getDeclared constructor is actually reflection. Reflection is not cheap or available in all platforms. So there is a library from JetBrains that provides reflection on all platforms that's called kotlin.reflect.full. This library is a bit heavy, like large in APK size and all. And it does provide the create instance method that we actually would like to have. But if we include that in the view model library, that would increase considerably the APK size of everyone that actually uses that view model. And it was a bit too much to introduce a whole library that's quite large because of a single method to create instances. So the learning for this case for us has been not all APIs are worth to implement in all platforms. Some platforms are really good doing something, others are not, or they have different trade-offs. So you need to figure out which APIs are actually worth it to bring to these platforms. For the Android view model factory, which is the specialization for the instance factory, that's going to be quite quickie, actually. If we expand the content, you're going to see that it takes in the application android.app.application. What the name suggests is an Android-specific class, and there is no actually way, like, this doesn't translate well to other platforms. Also, it would be very weird to have an Android view model factory class in your common source set. So the learning here is that not everything that you have today of features needs to be necessarily commonized. It's okay to actually rethink some of them and not commonize them. Okay, so let's take the view model provider now and actually make it available to all platforms. As we discussed before, we're going to be commonize just some of the APIs, not all of them. And we do that by adding the expect keyword in front of the class. In case you're familiar with the KMP expect actual keywords. And each platform, or each platform that requires this implementation, will have a variant of this file that's going to have the actual class view model provider. Basically, we are going to be converting these three, the function get, the factory interface, and the companion object. And the thing here is that the function get is basically shared between all platforms. So the first assumption that you would have is, okay, some of the constructor, the new instance factory, the Android view model factory are specific for Android or JVM. We don't need to port that. They're going to be put in the actual class of that platform. But you would assume that, okay, the get method can be shared, so maybe we can implement the full implementation and just call it a day. But actually, expect declarations don't support the full implementations, so you need to handle that by yourself. So if we do count the number of view model provider, probably this is from like 2 or 3 months ago, maybe there is more now, per platform, we would basically get 3, the desktop, the Android, and the non-JVM. We really don't want to triplicate that. So we want to have one single behavior implementation and just share that and just have to test it once and be happy with that. So what we can do here instead is we can introduce a new class that's going to hold the behavior and data of the view model provider. We are basically moving the content of the view model provider to a different class. And the actual implementation of each platform, in this case is the Android one, the actual view model provider class, we'll just create an instance of this view model provider imp, and it's going to pass forward all the calls to that class. So we do that by actually introducing a private constructor that takes in a view model provider imp. This view model provider imp has all the implementation from the view model provider that used to live in this class, and we are just calling imp.getViewModel when get is called. And this class, basically, nothing really changed here, but there is one thing I want to call attention, which is this model class. As we discussed before in the previous slide, the Java.Lang class is not available on the KMP. So we had to change that to a key class to make it work, which seems a reasonable thing to do. So factory.create now takes the model key class, model extra, and everything work. And that caused us to revert a 2 years old fix of an issue when you had the sugaring enabling your project with compile only to specific libraries. So for example, if you use something like carry, that would crash your project. And this was fixed on 2.8.2 of lifecycle. But let's see how to actually backport the change. Basically, we changed the factory.create model class, model extra, to an expect function that's going to be called createViewModel, receiving all the parameters. The expect function works similar to the expect class, but actually works exactly the same as expect class. And for all platforms that are not Android, we're going to simply call factory.create model class.extra as before. However, for Android, for compatibility issues, we need to handle that by ourselves. So we're going to try catch the method, and we're going to basically brute force each one of them to see which one works. So we're going to start it with a create model class with a key class and an extra. If that throws an abstract method error, we're going to try that with a Java class.extra. If that throws an abstract method error because the sugaring removed this method, we're going to try the model class with the Java, which is the original method that used the empty default creation extra by default. And that works and fixes the problem. So what we did here is basically we have this view model provider class that is separated by the three platforms, desktop, Android, and non-GVM. And we have the shared view model provider implementation, which is an internal class that we use to share behavior and data, which calls a specific create view model for each platform to make sure that the Android one behaves as it used to behave. So the learnings here is, first is that expect classes cannot have default implementations, so there is an issue open, and I hope the JetBrains fix that. But for now, you do need to implement that by yourself somehow. So it can be functions, it can be classes that extract if you need behavior and data together or whatsoever. The sugaring modification can cause side effects that is very tricky to track. Like you actually don't know exactly if you don't know the problem, it's very difficult to actually see that this will cause a problem because it happens after the sugaring and modification happen in the source code. Once you know the problem, you can write, like we did, tests to ensure that this will never happen again. But you need to be aware that touching your code and commonizing your code can cause problem in clients that use the sugaring modification in some cases. And you can mix and match expect and actual keywords to share as much code as possible. But just a heads up here is that if you do use expect and actual, like you saw before, you're actually creating more branches of behavior. So depending on the platform, the combination might change, and that's a different behavior. This means that you probably want to have more tests that covers all of these different behaviors paths. So ideally, you do want to write as much as possible common code, and you just leave the expect and actual for case that you really, really have to specialize for the platform, and you write tests to cover all the platform behavior. So for the view model class, the view model class is probably the most known API from the view model library. Everyone that uses the view model library will extend from the view model class, and it's going to be retained in the memory in the model as probably you're already familiar with. The interesting APIs here are not the ones that most people use the most, like uncleared, is actually add closable and get closable, which are APIs that allow you to bind a resource to a view model lifetime. So basically, this API allows you to say, I have this object that is a closable. I want this closable to be closed when the view model is cleared. And when the view model uncleared is called, everything that has been added to it as a closable is going to be closed together. You can also use the get close, passing the key string to return a closable that has been previously associated with the view model. We actually use that to write the view model scope. The view model scope is a closable included using the add and get closable APIs. The view model scope is a pre-configured coroutine scope made for UI operations, basically. So you don't need to create one and do all the dispatcher main with supervisor job and so on for you. So for the add closable, if we expand the closable package name, we get the java.io.closable. As we've seen before, Java types are a bit difficult to handle, like compatibility-wise. So we need to change that to something else. Java.io.closable actually extends another interface, I think, called java.io.autoclosable. And the autoclosable API has been backported to KMP. So we can change those APIs to actually use the autoclosable. Because closable implements autoclosable, that maintains binary compatibility at some degree. The Kotlin.autoclosable is a type alias that's going to target the correct implementation based on the platform. So if you're running GVM, you're targeting the java.io autoclosable anyway. If you're targeting other platforms, you're actually introducing new out-closable interface. That works well for the point of view of binary compatibility, like they're compatible, and for the add closable that takes in the key and the get closable that takes in the key, we can just do the change because these APIs we were very lucky and these APIs were not stable when we actually did this conversion. However, the first method, the add closable, is actually a stable API, and we want to be sure that this still keep compatibility with whoever used to call that method. And we do that by introducing a copy of this method, duplicated, that actually still takes in the java.io closable. We annotated it was deprecated, and we said deprecated level was hidden. So you cannot call this method by yourself. If you try to call add closable, passing any closable instance, you automatically go to the out closable because they implement each other. But if a library has been compiled against the java.io.closable, we want to be sure that this library still works with new versions of the view model library. We don't want to ask everyone that built a library that used this API to update their API with our specific version. So we do that by the deprecated hidden and leaving that there. Also, because we did that, and the java.io.closable is a Java-only type, we do need to duplicate the code again. We need to introduce a new expect class. We need to introduce, in this new expected class, Android variant that has that method, and that method does not exist in other platforms. So if we count the number of view model files again, we get the JVM and the non-JVM. The JVM one contains the hidden method, the non-JVM doesn't. We do exactly the same approach as before. We create the view model implementation instance, and this view model implementation basically takes all the behavior and data from the view model. It used to live here, and all the actual implementation of each platform will simply call and pass forward any method call to this new instance. So the view model implementation actually works quite well with KMP, almost without any change. But there is one thing here that actually is not supported by KMP, which is the synchronization. The view model implementation uses synchronization to ensure that when you add a closable or get a closable, you are safe that that will be a unique instance. And because that's not supported by KMP, we do need to implement that by ourselves. So JetBrains does provide a library that has synchronization support for all platforms, but this library is called Atomic Foo, and this library is experimental, and this library has a package inside it that is locks. And if you do check their README file, they're explicitly about how experimental that is. Like the library is experimental, and the package is experimental within the experimental of the library, and there is no ABI guarantee or any guarantee at all. Yeah, so we cannot put that in a stable artifact, like lifecycle and ship view model and ship that. So we need to implement that by ourselves. In this case, we do want to have an API that is very similar to the API that we are familiar with. So once, hopefully, this gets stable, we can actually replace that to use the Atomic Foo one. So how can we do that? We can introduce yet another expect class, a synchronized object. We can introduce a final inline fun synchronized that calls a synchronized implementation that is going to be an expect function that has the implementation of this synchronization. You might find a bit weird that there is a synchronized and a synchronized impl. And the reason that we need to have those two is because we use the contract to give more information to the compiler when the synchronized function is called. And as it seems, contracts are not supported inside the expected declarations. So we had to create a new function that's final, create an expect function, and then call the expect function from the final function. And these allow us to work around and be sure that the contracts works as expected. We can still use contracts and still have the expected implementation. So for JVM implementations, it's quite simple. We can just call the Kotlin.synchronize, the API match, so the API signature match. So we just pass forward the parameters, and that's it. For native, though, we do need to implement that ourselves. We won't be covering all the implementation, but I will just call attention for some specific points. Basically, how it works is that the synchronized receive is the synchronized object. It's going to call lock, call an action, and unlock when it's unlocked. And this lock and unlock, we'll need to use native APIs to understand when to lock and unlock the resource. So if we go to the native implementation and check the synchronized object implementation, expanding it, there is a bunch of things that have been omitted, but you will notice that there is this annotation called experimental foreign API. And the first thing is that even us trying to avoid the atomic full locks that is very, very, very experimental, we still had to use experimental functions to actually use that. But we did avoid adding a new dependence that would cause other buttons. The second thing is that the experimental for an API basically is Kotlin multi-platform is really powerful, and one of the main advantages of Kotlin multi-platform is that you can have interoperability with the platform system. So you can call native APIs, and you can take advantage of that APIs that the platform in itself is providing. You don't need to reinvent the wheel and write bridges and connect with everything all the time, every time. It's also more performatic to not have to do this bridge and do the native calls itself. The downside of that is that you do sometimes need to touch these APIs, so you might need to learn the specific platform APIs and have to handle that by yourself. And some might be still not, the API that you consume that from Kotlin might not be yet stable. So ideally, with more libraries and APIs being converted to Kotlin multi-platform, you're going to end up in a situation where these APIs will be all uncommon and you can just call them and you don't need to worry about these things. But while we're developing libraries for this ecosystem, today at least, you would need maybe to implement them. Another interesting thing here is that you're going to see that there is an expect val for a integer. And the reason that we have that is because this mutex recursive flag actually is defined slightly different depending on the platform. So basically, this flag has different numeric types depending on the platform, and on Dowring, this is a signed integer. On Linux, this is an unsigned integer. So we actually need to make expect actual, convert them to the correct type. Now, there is an open issue to improve that experience, but yeah, today that is what works. So, the view model scope. The view model scope uses the APIs we saw before, the synchronized that we created internally, the get closable and the add closable, and it returns a closable coroutine scope, which is an internal class that implements out closable. Whenever the close method is called, the coroutine context cancel is going to be called together, so we assure that the coroutine scope does not overleave the view model once uncleared happen. You can actually use this API to write your own extension in the view model if you like. The interesting point, like this mostly work, but dispatcher main is not available on all platforms. So we cannot just call dispatcher main immediately here and expect things to work. This might throw, and they might throw different errors depending on each platform. So we need to handle that ourselves again. We do that by creating a new function called create view model scope. This is an internal function. And this create view model scope, different from before, we're not going to use expect and actual and do it different for platform. We're going to actually handle those errors on the common source set. Basically, on Android and any platform that has a dispatcher main, we do use the dispatcher main. If there is a not implemented error, normally in environments like native Linux, we actually fall back that to empty coroutine context, which is the default coroutine context. So we basically don't do anything there, we just use the default and that's it. If we do get a legal state exception in environments such as GVM desktop using Swing, we do the same, we fall back to the empty coroutine context. Finally, we do return the closable coroutine scope, passing the dispatcher plus the supervisor job, again as before. So the learning here is not everything has to use expect and actual declarations. You might use that when you find valuable, and it's very powerful, but sometimes it makes sense and it's fine to just implement the method and handle the case yourself. So do that case by case, depending on what you need. So the three main key takeaways from our experience with lifecycle libraries are, the first is that you do need to strive to find a balance between the minimal change in the API and the best possible common API. We do want to provide a really amazing common API for Kotlin multi-platform clients, but at the same time, we do have a responsibility with all the apps, probably all the apps that you folks are building, that they would still keep working with new versions of the library. So that is something that you need to find a balance. That might not be that extreme for other library authors, but for us, that's a big deal, and we want to be sure that there is minimal impact on the Android development ecosystem. You can reuse the knowledge, so if you do have develop a library and that is already being used by hundreds, maybe thousands of people, you can actually learn from the experience of these people and talk with them and try to understand which APIs make sense to convert. Maybe there are APIs that can be sunset. How should you do this or that? So you can reuse the knowledge of what you already have. You not necessarily need to rewrite everything in the Kotlin way of doing things and just go randomly in that. So my suggestion here would mostly be reuse what you have, and then after that, you think about how can you improve things. Also, in case you have to duplicate methods like we had to do for binary compatibility, try to keep those API signatures as consistent as possible. So that helps with developer discoverability, so they kind of have a better day finding what method to call, and so on. Last but not least is that Kotlin multi-platform is very powerful. We did have a lot of annoying roadblocks that we had to deal with. At the same time, we also converted a library that has been developed 7 years ago for Java all the way to Kotlin multi-platform without breaking binary compatibility and make that run everywhere. So that just shows how much flexible and how much powerful Kotlin multi-platform is already today. That's all I have today. Thank you. Are there time for questions or no? If there is any question, otherwise just come talk to me down.